right, it's past 3 o'clock, so it's time to start. Good afternoon, everybody, and welcome to this presentation of the master's program in music and acoustic engineering. My name is Augusto Sarti. I can see that there is quite a few people already connected from remote locations, not so many in presence, so only the privileged one who are here will receive a t-shirt and whatever has already been set up by our very efficient secretariat here. I'm very happy to introduce the master's program in music and acoustic engineering for a variety of reasons. As a founder of the program, this is, as far as I'm concerned, really a dream come true, as far as I'm concerned. When I was your age, earlier than that, when I decided to sign up with engineering, that's what I wanted to do. So it's been a long-standing dream to join a program that will have something where engineering, where science comes together with music. And there wasn't much, because that was, I'm not even going to tell you what year that was. It was a long time ago. There was one course I remember in Padua, and the course was named in Italian, the equivalent of computer music. I was very happy to do it. We were working on, we were doing projects, and we published even a project in a conference. It was really fun. And that was the very reason why I decided to join engineering, because, you know, I still have a post-image of myself as a musician, but I knew that I would be a much better engineer than I would be a musician. So I decided to go for the other career, and that actually worked out pretty well. I'm giving you this section of myself because I'm sure it matches most of that of the students that want to join. I can see lots of people nodding their head. Yeah, there is nothing to do. Music is something that captivates everybody's love, attention, emotions, and so on. And when you put it together with science, it becomes incredibly powerful, incredibly powerful. There is a lot in common between science and music, and it's not just when you see, you know, the classical image of Einstein playing the violin. That has nothing to do with that. It really has nothing to do with that. Science and music come together because it's the same mind frame. People that make music, that write music, think the same way as researchers. And when they create something new, they use exactly the same approach. I don't know if you, I hope that you will have this chance of experiencing the thrill of solving problems, and you will realize, if you are also musicians, that it works exactly the same way. You come up with original idea, and you try to make it as artful, interesting, enticing, and compelling as possible when you present it to your boss or to the people around you. You learn how to do it together with others, because like music, science is done best when you do it together with others. We're not Americans. I come from an American university. I studied in Berkeley myself. In Berkeley, the way we studied was everyone from themselves. And not because I wanted to, but because that's the way things worked. We were there, everybody was hiding the notes from everyone else because it was all a competition. That's not how it works in Italy. We have a large research group with over 20 people working in there, plus all the students that do master's thesis. If you count everybody, it's over 70 people working toward a common goal, improving the science of music. And it's a very, very collaborative work. It's very generous work. People work together, they form a community, collaborate with each other. There is a lot of democracy at work there when we do work together. And it's a system that it took us 30 years to develop, but it really works well. Every student that does a thesis in music and acoustic engineering has assigned a tutor, a PhD student, that will follow the student throughout the entire path of preparation. And so it's not like in many other universities where you beg for someone who will be your supervisor, take the thesis at the last minute and hope with your finger crossed that your thesis will be presented eventually. No, this is not how it works here. 80% of our theses are published in international conferences. They work hard, students work hard, but they are happy to work hard because they do it together with the real researchers those that do that as a job. And it's a daily interaction with them and among each other. And the result is fantastic. Every time you just come to one of our presentations of thesis presentations, it will be like being in an international conference, because that's what it is. Most of the theses are at conference level. Well, after having bragged about it for like 10 minutes, let me talk about music and acoustic engineering. This is actually the starting point of everything. We wanted to set up the system this way, and we designed the program in such a way that it would have, it would support this system. In such a way that everybody learns how to be a researcher, whether this researcher will work in a university or whether the researcher will work in a company, the mindset is always the same. And industrial research is not dissimilar from academic research. And this is what we train people for, to learn how to solve problems, tackle them, come up with creative ideas, and apply it not only to everyday problems, but also to creative problems. Anyway, music and acoustic engineering, let me go on, otherwise I won't have any time to tell you anything about it, is a master's program that has a number of things that you need to know. First of all, it's within what we call graduation classes. For students who come from abroad, this means nothing other than for one piece of information that I'll give you in a minute. For everyone else, a graduation class is classification done by the government, so in order to guarantee certain type of quality and standardization and so on. The graduation class that this degree belongs to is LM32, which technically is information engineering, which is good because that's what we do. We actually do something that is much broader than that, but at the end, it all boils down to processing information in all possible forms, whether it's acoustic information, whether it's audio information, space-time processing, all kinds of things that we do, they all fall into the wide category of information engineering. There is, this also means that you will find all the information you need about the course in two websites. One concerns the school. The Polytechnic has 4 schools, I believe. Oh, God, I'm totally unprepared now. Yes, 4 big schools. One is the largest one, is the 3I school, Industrial Information Engineering, and the website is the one that you see right here. And this contains all the program, the organization, the course rules, the rules for setting up basically the study program, which has to be approved, and you will have to follow that study program. There is also a reference website, which is suono.polimi.it. There is a Facebook site, which I recommend you to take a look at, because on that website you can see how many seminars, how many activities take place. You probably have already seen that, some of that, but we have at least 1 or 2 seminars a week with famous musicians, with researchers from all over the world. We have experts in music making, musical instrument making, all kinds of stuff. So it's always good. People that are not even sign up with the program can still participate to some of this activity from remote. Last week, for example, we had Francois Pachet, who's the director of the Spotify Labs in Paris. And actually, Francois Pachet ended up playing with us in a concert that involved also some of the students. I don't know if any of you were there in Mantova. And it was really fun. And lots of engineers, scientists, musicians, and many professional musicians were there. We had a ball. Students also that participated. Say the best students of Polyphonia were selected to participate there. Also had a great time. And so music happens also in here. And it happens with the very people that you heard about, maybe in the scientific realm, like in the case of Francois Pachet. There are also a couple of videos here. They're kind of handmade because I filmed it while I was at home, stranded at home due to COVID. So you don't see any of the labs, and I apologize for that. But you see me in my own place, surrounded by my own instruments. So that's my personal lab at home. So I kind of brag about it because it's kind of fun. We'll update it whenever we find a little more energy for doing that kind of stuff. But there is all the essential information there if you are interested in. So what is music and acoustic engineering? How was it conceived in order to offer this kind of variety of ideas? First of all, the name also means something, and it can. It took us a long time to figure out a name that would fit. Music engineering and acoustic engineering are usually two completely opposite worlds. Either you pick one or you pick the other. So sometimes you find courses that offer you a little bit of music engineering, not much. Some others just entirely focused on acoustic, hardcore engineering, you know, and it's usually part of mechanical engineering or other courses of vibration engineering, that kind of stuff. We tend to look at acoustic engineering, again, from the point of view information engineering. And it actually is working really well because thanks to that, acoustic engineering has grown a lot, especially with the intervention of machine learning, machine intelligence. We're doing rather, can I brag about it for a second? We are really doing amazing things. So there are already 2 articles on Science, on Science that came out that talk about how we do, for example, the modeling of the sound plates of violins using machine intelligence. And so all these things are a proof of the fact that putting together the mind frame of an information engineer and the mind frame of an acoustic engineer, you can do amazing things. But as you know, the explosion of these 2 topics is to be somehow connected to the idea of the role of audio, sound, acoustics in information society. Audio has always been a driving force in information society. First, you had the radio, and then you had the TV, and now you have the internet, but the audio has always been a driving pilot, an essential component. It's very hard to follow something without the audio. It's pretty easy to follow something with only the audio because it contains semantic and emotional information, speech, music, and so on. Watching most of the movies without the soundtrack loses completely the meaning. Try to watch, I don't know, the English Patient without the sound, kind of loses a lot. But that's not the main reason. Anyway, the expectation also people has been growing in the past few years because people expect high quality audio, they expect high-end audio. In the concert we did last week, we were using for the first time 3D audio, immersive audio in the Opera Theater of Mantova. So we had arrays of loudspeakers which were developed here in our labs here. And for the first time, you could experience 3D sound in a theater, in an opera theater, no less. And so that was a first proof of the fact that, you know, when you do things intelligently, you can really bring this stuff in everybody's home using reasonably inexpensive material. And this is our goal, is not to do things that only super high-end things, situations can enjoy, but we want to bring quality at home and also teach how to do music that actually embraces everybody, not just the selected people that, you know, are obsessed with music. We need to educate also listeners to grow up with music. And so the technology that we want to develop go also in that kind of direction. As far as acoustics is concerned, the situation is absolutely the same. Acoustics not only does it consider environments, especially the well-being in specific environments. So, for example, these are examples of places where the acoustics have been studied in order to create comfort or to create a listening experience, a fantastic listening experience. This is, for example, the Arvedi Auditorium here in Cremona, where our musical acoustics lab is. It's right behind one of these seating arrangements. And but it doesn't include just that. It also includes vibration analysis, acoustic noise, and so on. This is a system for obtaining holographic measurements of the sound produced by tires, rolling noise produced by tires in cars. This actually is being used in Pirelli, to give you an idea. You can use similar techniques for elevators. A lot of stuff was done with Conan, for example, or other companies in that direction. Well, you can also work in industrial sites to do noise and analysis and surveys and kind of stuff. But there is also, in acoustics, there is also the aspect of the design of musical instruments. We have a course that is entirely devoted to musical acoustics. So to study and understand the physics of musical instruments. These are some of the companies we work with, but we had a couple of years project with them. We have interactions with other famous musical instruments. Polo is, those of you who play a saxophone, as of course a mythical company that makes incredible saxophones, and of course, Luthiery. So violin making, we are in the cradle of the world cradle of Luthiery, and so our laboratory, there is one laboratory entirely devoted to how to make the best violins, and don't say this around because I'd be crucified, how to do better than Stradivari. Don't say it around because it's dangerous. We can do better than Stradivari. Yes, we can. So if that's a question, that's my answer. Yes, you can. And the way to do better than Stradivari is to use your brain as a scientist, right? Creative technology is another famous component of engineering. Creative technologies are now becoming very, very fashionable. We started talking about it years and years ago, but we have courses devoted to this idea. We have advanced coding tools and methodology to begin with, and creative programming and computing, by the way, who's taught by a very interesting person. He's a PhD in information engineering, published a lot in music information retrieval field, but at the same time, he's also a music producer, an agent, and an organizer of events. Just to give you an idea. So we have this mixture of figures that you can't find anywhere else. Even music production technology is being taught by Vittorio Cosma, to give you an idea, Lorenzo Cazzanillo, who are very famous producers in Italy, and also musicians as well. So creative technologies are now pervasive, and you know, Politecnico Milano being the Olympus of the technology, I should say that with a booming voice, but right now I better not do it, has decided to embrace it. And it was about time, for crying out loud. It's always been this austere image of massive institution with 50,000 students graduating 20% of the Italian engineers and never talk about art other than in design. For crying out loud, we are in engineering. We have probably the most creative engineers in the world. Let's talk about creativity for once. And so that's the idea of starting with this program. And going on, but there is a lot of attempts in trying to do something of the sort. We actually worked a lot with Stanford University, and we're still working with Stanford University. Our collaboration dates back 30 years ago. We are publishing stuff together, but they don't have a program of this sort. They have a PhD program with a limited number of students. Georgia Tech has a program, but they're all limited to one of the aspects that we try to cover. Carnegie Mellon, by the way, Carnegie Mellon is $60,000 a year of just in tuition. Sorry, Carnegie Mellon. But we don't cost that much, and we do a lot more. And by the way, we're ahead of them by I don't know how many positions on QS ranking. But I don't know if you guys know, but we are 13 in the world in engineering and technology, ahead of Caltech. I need some applauses here. We're ahead of Caltech, which, by the way, has an endowment of $5 billion. $5 billion is an economical maneuver. We call them like that in Italy. So you can probably save a truckload of an entire country from famine with $5 billion. And yet we are 6 positions ahead of Caltech. So there is something to be proud of about the Politecnico Milano. Let's enjoy this thing and let's do the best we can with that. There are many other programs around. Francois Pachet, who was here with us just last week, actually until yesterday, he worked for a few years in IRCAM, and this is a fantastic institution, but it's very, very, up in in the air, does very theoretical things. We try to be more, everyday technology for everyday people. We believe that music should be everybody's enjoyment, not just if you are a musicologist, So we have a different mindset from EURCAM, and actually it's exactly the same reason why Francois Pachet moved from EURCAM to Sony Music and then eventually became the head of research in Paris for Spotify. And so all the programs that are there are actually excellent programs, but they're limited in coverage. We're very proud to be able to say that the Master in Music and Acoustic Engineering is, in fact, the one that has the largest number of credits devoted to music and acoustic. We have something like 150 ECTS credits devoted to it, and a bunch of other courses offered by the Conservatory of Milan, the Department of Musicology of the University of Pavia, through exchanges of courses with them. And of course, all the courses that are offered by information engineering and the master's program in information engineering, informatics engineering. So we cover a lot of stuff from music informatics, audio and acoustic signal processing, musical acoustics, applied acoustics, architectural acoustics, computational acoustics, creative programming and computing, as written there, machine intelligence in audio and acoustics. There is a lot of stuff. And also simulation, there is virtual analog modeling, there is synthesis, there is analysis, and all kinds of stuff. Of course, you can't take all 150 credits. You have 100 credits to do, so you have to be selective. Depending on your background, you have professors that help you make a good choice for the courses. And so this is kind of an iterative process in order to get down to the final study course that allows you to do things in the best way. Well, you are very much aware that we do things in English. And I say, thank God, not just because it's important to learn English, but because, honestly, if I had to do one class of what I teach in Italian, it would take me 50% longer. Because the Italian, unfortunately, is not very well specialized for teaching things about technical things. And so it's a lot less effective in that sense. Well, this I've already told you, engineering and technology, we are 13, so it's not, I was being wide and saying top 20, we're top 13, so it doesn't work that way, huh? Okay, we're nearly top 10, okay, let's put it that way. A little bit of a history about music and acoustic engineering. We started out, we didn't start in 2018-19 as officially it seems to be. We started much earlier than that. We started in 2005, 2006. Back then it was just a track of 25, then became 35 credits within computer science and engineering. It was offered in a different city, it was in Como. Then we moved to Milan in 2016-17, and it was called the Musical Acoustics. And this time it expanded with many more credits. Then it was embraced the year after also by telecommunication engineers. So it became a full-blown program belonging to information engineering school, not just computer science and engineering. Finally, 2018-19, the government said yes to new programs, and we were right in pole position with the program already set up, and we started that same year. So the first graduates were in the year 2000, 3 graduates. So it was kind of a very restricted ceremony. But one of those graduates is now one of our PhD students, so they were excellent candidates. And the last graduation ceremony had 22 graduates. It was really like a conference, like an international conference, like I said before. So it's growing, and today we have an average of 85 to 90 new students per year. And I can rather safely say this is the largest number of students you will ever see in this area joining a program in the world. Just to give an idea for comparison, Queen Mary University of London, which has a fantastic program, Mark Sandler is a very dear friend, and he has a fantastic program in London. They offer a similar program that covers a little bit of music engineering, much more than acoustic engineering. And they have 12 students a year, 12. So that gives you an idea of the difference in size. They're also not equipped to welcome many more than that, to be honest, because it's really hard to keep up with many students in a situation where it is so specialized. But, you know, it's also a good sign, because it means that students are appreciating. There is always, you know, people talk to each other, students talk to each other. And I think the best thing, the best quality that this program has is really the community that is formed among the students. They help each other. There are several associations that help out with that. And it's a fantastic deal, in my opinion. So, as mentioned before, we have two didactic tracks. One is called Acoustic Engineering, which, well, everything is obviously managed here in Cremona, because it's a program that lives in Cremona. But we have two different tracks. One is called Music Engineering, the other is called Acoustic Engineering, that are best located in two different places, which is, obviously, it's kind of a drawback, because being in two campuses that are quite far from each other creates some logistical problems. But we did the best we could in order to overcome such problems, but I want you to be aware of this. The reason why acoustic engineering is here is obvious. We are in the cradle of musical acoustics, and we have been supported so much by the city of Cremona. We even are going to move into a new building in the center, the historical center of Cremona, thanks to the support of Cremona. And so there's been a huge, huge, huge support for, and the community really wanted this degree to flourish. And so we owe it to them, and we think it's important that it is here, because this is the campus that wants this program the most. And that's what we're going to do. We're going to stay here and make it flourish here. But at the same time, we are also aware of the importance of being able to offer the students the possibility to expand if they decide to do music engineering. Music engineering is more like information oriented. And so students need to be able to access a wide range of courses in information engineering. In particular, all the courses in machine learning, all the courses in data mining, all the courses in, you know, the computational intelligence, computational creativity. It's a terrible word, but anyway, people call that too. All these courses exist, and we could only cover 150 credits, which is a big number, believe me. But by keeping that program, that part of the program in Milan, allows us to give students access to the courses in computer science and engineering in Milan. Plus, there is one more thing. In Milan, there is also the Conservatory of Milan. We have an agreement in place between the Conservatory of Milan and the University of the Polytechnic of Milano. And so there is a possibility of exchanging credits. So you can take courses at the Conservatory and vice versa. And the students of the Conservatory can take courses in our, from music and acoustic engineering. The first year is very similar for both tracks. Most of the courses are the same, which means you cannot duplicate them on both campuses. And that's where you might experience some differences from other courses. This is the only one that is split over two campuses. When I teach a course, for example, computer music representations and modeling, when I teach these courses, will have to be attended by both students in Milan and in Cremona. So what do? We have a nice teleconferencing system, 350 rooms of the Polytechnic are covered with a nice system based on WebEx or other codecs. We have arrays of 256 microphones in each room, Zoom cameras, all kinds of things. So it's not so bad, but at the same time, students need to see me. So what do? I teach one day I teach in Milan, one day I teach in Cremona. I move around between the two sites. So when I don't teach in Milan, students attend from home or from the classroom, which is still set up to be present. Sometimes we even do classes simultaneously. So there is the assistant, the teaching assistant in one room and the professor in the other room, and we kind of exchange things between the two rooms. So that's how it works, to give you an idea. Some are exclusively offered here and not in Milan, or vice versa. For example, the musical acoustics is just here. Room acoustics is just here. And these courses are just designed, or, for example, simulation. Acoustic simulation is taught here exclusively. So they are only designed for the students in Cremona. What does an acoustic engineer do? Well, that's pretty well known. They are expert of vibrating and resonance systems. So what they do is to focus on whatever vibrates. So it could be musical instruments, listening spaces, architectural acoustics is another aspect that is addressed. Materials, you address the issue of acoustic materials. You can also do active acoustics, so noise reduction, noise control, vibrational control, and so on. These are some examples of applications. These are materials designed in collaboration with the architectural department. You should know that we have a laboratory called, a network laboratory called the Polini Sound and Vibration Lab, which has the participation of our aeronautical engineer, in addition to us, obviously, aeronautical engineering, architecture, energy engineering, and mechanical engineering. So there is a little bit of everything in there in the lab. And so these are images from that lab where you have acoustic cameras, where you can build arrays of microphones in order to do an image, the acoustic image for acoustic surveys, and so on. I said before that it's offered in the campus of Cremona. You have already probably seen the city. It's beautiful, and it's also the UNESCO site for intangible cultural heritage as far as luthier is concerned, the art of violin making. That's not a small thing. In fact, a lot of our research, we have one lab that is devoted to that, is exactly inside the Violin Museum of Cremona, which we'll make sure you can actually visit. And there is also a virtual lab that can be done there, because the access is limited, obviously, but we can still do virtual labs remotely for that. Okay, this you know because you're already here. What kind of jobs can you do in acoustic engineering? It's pretty clear. You can do you can be hired for the production of musical instruments. You can work on the design of systems for sound diffusion, so loudspeakers, amplifier, PA systems. We do a lot of work with these companies because Italy has many, many of such companies in there. We did 2 years of projects with, for example, BNC speakers. We're working with Bowers and Wilkins. We worked with Fraunhofer and Sennheiser. Some of the stuff that you see around is actually designed by us, including the famous soundbar of Sennheiser that was actually designed here. Also, there are companies that work in microelectronic devices, transducers, sensors. And I'm referring to ST Microelectronics, with whom we already have 3 scholarships for PhD students funded by them. We have a large project in place. We're working with Inventum, which does piezo screens, for example. We're working with Electromedia, who does linearization of loudspeakers. So we do digital signal processing for linearizing the non-linearities of loudspeakers, which, by the way, happens to be the topic of my PhD thesis many years ago. It wasn't exactly on loudspeakers, but the inversion of the nonlinear system was my topic of study back then. Also, you can work for environmental or industrial acoustics. So you can work in large companies that are interested in acoustics. The strange example of before of Pirelli is one such example. So the noise produced by the rolling of tires, for example. Musical engineer is something that didn't exist before. We made it up from scratch. We're very proud of that because it's a figure that is going, in my opinion, to explode. You know that there are streaming services are growing left and right. You have a search for audio information or multimedia information where the leading element remains the audio part. For example, we are working with, we have a large contract with Auditel right now in place, and they do search of multimedia content based solely on audio. So we do classification of content in streaming based just on the audio. You recognize news, you recognize soundtracks, you recognize interviews, you recognize environments, the size of the environment from the sound. You do all kinds of things that you do using techniques that are based on audio. So just monitoring, audience intelligence, it can be based on audio. Understanding the emotional status of a person can be based on just the analysis of the speech. You can create personalized multimedia stream. Live performances as the artistic installation can be emphasized with special technology, the design for the spot. A group of students every year goes to Festivale in Sicily, which is led by a former graduate of music and acoustic engineering, by the way, of what was called sound and music engineering before, Fausto Sabatteri, the leader of a group called 4 and 6, which, by the way, played with us last week. So this fantastic Manouche guitarist. He leads a group of students every year to the Festivale in the Valle dei Templi in Sicily to do this jazz festival and create technologies for this festival. It's a fantastic experience. They have a vacation too, by the way. I'm very envious because I'm always in the US when they do it. So I've always missed it in person, but then we take it back to Milan, and when we do a festival of some sort, we use the same technology here. That's kind of a fun thing. Music production is another aspect, so all the software for music production can rely on this sort of things. So music engineering is very interesting because, and it's becoming more and more interesting. It relies on this relationship between Politecnico di Milano and the Conservatory of Milan, which has been in place for a rather long time. And the profession is ever evolving. You can work for all these brands that you see here. We have many people that are now sparse all around the world doing this kind of job. A former graduate of ours, for example, Bruno Di Giorgi, who, by the way, some of you might know him because he's an amazing guitarist. He did a PhD with us, and now he's the head of a laboratory of Apple Music in London. We have people that graduated and then moved to Facebook, Google. Clara Borrelli has just been hired, who's used to be my teaching assistant in the course of computer music representations and modeling, now has been hired again by Apple Music in London. So that we're losing them all to these companies. But I'm happy that they get positions of responsibility with people in NVIDIA, in Google California, NVIDIA Zurich, etc. There are also possibilities in advertising companies or audience intelligence, music distribution, all kinds of stuff of that sort. And it changes every year. So if you ask me the same question next year, I might answer differently because new ideas pop up and you have to design your own life somehow based on what you see that the needs are. And there are always new needs for technology. We don't have real job stats. So if you look at this in the hope of finding real numbers, no, these are imaginary numbers. But they're actually quite reliable in the sense that we are in this area, computer science and engineering. And so what we see now, which is 97% occupational index, 98% is 97.9, is actually quite reliable. We have none that hasn't found a job immediately or even before they graduated. So we're very happy with the outcome. So I think we're closer to telecommunication engineering, 100% hiring percentage than anything else. You know, there is a hunger for engineers, especially if these engineers are creative. Let me say a few things about courses because I think it's interesting. There is a course that I'm teaching that I'm very proud of. My wife almost killed me because I was doing that course. She thought that I wanted to teach music. And I said, no, that's not what I want to do. I want to teach how to extract models from music. And that's why it was called computer music representations and models. And I was very tempted to call it music representations and models. It's the only course of the sort in the world. And actually next year, we're going to have also Francois Paché helping me out with that course. I've had Daniel Levitin helping me out with the course for music cognition part. In the past, I've had Yogav Gabay, this amazing drummer from Israel, helping me with rhythmic part modeling. And he was the drummer of Tigran Amassian, for those of you who know Tigran Amassian. Anyway, so we've had all kinds of guests helping out with this course. So, and I've never learned so much. I was supposed to teach the course. I ended up being the students more than anyone else. I learned so much from it. We had people from all over the world that came to do presentations. Stanford University, Imogen Heap came 3 years ago. We had Yogav Gabay. The class of Yogav Gabay was quite full, as you can see. Thanks to our secretaries, we emptied this building, the entire building, to do a class with him on the drums. And it was very noisy, but it was one of the most amazing classes we've ever had. And which is the one that you see here. Every year we have a seminar from Davide Ruggieri. We had Dave Schroeder, the head of the music program at New York University at Steinhardt. So it's kind of nice because we talk about music, how to model music with the help of musicians. And it changes every year. Every year we have a concert, by the way, at the, it's called the Engineering Fest. Last year we had Matteo Mancuso and 4 on 6. And we all fell off the chair, obviously. And of course, the day after, we start music and acoustic. We start the academic year of music and acoustic engineering. The first class is, I pride about it, my course. And so they come, we do a workshop in my course we did it last year with Matteo Mancuso and with 4 on 6. This year, let me give you the information in advance. We're gonna have Simone Bollini Trio, one of the most amazing composer I've ever met, who happens to be a graduate of music and acoustic engineering. He's a Swiss jazz pianist. But immediately after, there will be also Alfredo Rodriguez Trio from Cuba. An amazing trio, they're a lot of fun, look them up. And they will be in the workshop the day after in my first class of computer music representations and modeling. So that also is a lot of fun. Why am I saying this? I shouldn't be saying this, but it's just that I'm having a lot of fun in that course. And so. What was I talking about? Computer music representation and model, and in parallel there is another course called Computer Music Languages and Systems, which is taught by a professor that is amazing at doing live coding, by the way. So we're not talking about people just talk about theory. They actually put it into practice in a very, very proficient way. Professor Bruschi. He's also an expert on non-functional tokens and all kinds of stuff, so it's kind of interesting to interact with him. In acoustics, we have a bunch of very, very interesting courses: fundamentals of acoustic, vibration analysis and bioacoustics, numerical modeling and simulation in acoustics, musical acoustics with room acoustics. All these courses, this is the richest selection you could possibly imagine for acoustics. And there are labs here in Cremona where you can actually do this hands-on. We're purchasing a small anechoic chamber for the electroacoustics part. I'll tell you more about it in a few minutes. So these are some images from there. For creative programming, there are the two courses, one that I mentioned before, Advanced Coding Tools and Methodologies, and Creative Programming and Computing. These are some images from those courses. Massimiliano Zanoni, PhD in information engineering, and a producer and an agent, all kinds of stuff. Is also a drummer, by the way. Everybody plays something. He actually worked with all kinds of installations in the past. And for example, we had a demo with dancing drones with LED lights doing choreographies. Was one of the first demos done in that sense. Now there are companies that do that all over the world. We've seen that. So it's really cool. Another course that is really fun, and I'm very proud to have brought it to this program, is music production technologies. Now, I kind of went against my own conviction initially, because I thought, we're not teaching how to, we're not teaching you to become a producer. Definitely not. But if you are to develop some software that is to be used in a production studio, how the heck are you going to do it if you've never been in a production studio in your life? So imagine having to do a project on some software on a new form of digital audio workstation. If you don't know how a normal digital audio workstation works, you won't be able to do it. So you have to do a course. It's a 10-credit course. And Vittorio Cosma, I hope you know, I'm sure you know him, is an amazing musician. He's well known in Italy, but he also has a super group with the drummer of the Police, the guitarist of King Crimson, the bass player of the Level 42, Mark King, and so he's a phenomenal musician. He teaches the artistic part of the course, while the technical part is taught by Lorenzo Cazzaniga, who's a very famous producer in Italy. This that you see behind them is one of the studios where the experiences are done, and that's the Alari Studios, and that console that is behind them is the same one used by the Pink Floyd. So it's exactly the same, it was purchased by them and then retrofitted to become digital. This one is another recording studio called Music Production by Vittorio Cosma. We also have in this building, we have the Studio Lab, which can be used. And we also have an agreement for the students in Milan with Blue Note Recording Studios, which is a small rehearsal area, but they also can, which we can provide the students access to. We have an agreement, we pay every year a certain amount of money in order to give hours to the students. So if you make a request for a project or something like that, you can definitely access that facility. Electroacoustics is also growing a great deal. The reason why it's growing, and I'm sorry I'm going maybe too slowly, is because we are in the land. Italy is the land of electroacoustics. There's nothing to do. Best loudspeakers come from here. There are lots of companies, KRA, Elettromedia, PowerSoft, and BNC speakers, and so on, that work in this area. There is a long tradition. Vital, today there is a seminar in Milan with Vital, by the way, within our course. So working in electroacoustics is very important, and we actually are very active on that. We are now about to open 2 new labs, for one didactic and one research lab of electroacoustics here in Cremona. You know, we're using some of the stuff that we teach in the course of sound analysis, synthesis, and processing, which I teach, about sound synthesis through physical modeling. Now they're used for doing the linearization of loudspeakers, modeling of piezoelectric loudspeakers, modeling of MEMS loudspeakers in collaboration with ST microelectronics. There are also lots of project activities. There is a course called Project Course, which next year will be called Music and Acoustic Engineering Capstone. And I have to say I'm very proud of that course, because it took us a long time to design it. It's the only course in the world that really trains you to become a real researcher. Meaning that you will be asked, you will be assigned a tutor for a small project, in group or by yourself, depending on what you want to do. And then you can focus on the project, but you will be required to do the proper literary review, state-of-the-art assessment, follow all the steps of good and sound research until the end, where you submit the paper to a virtual conference that we organize every year at the Politecnico. You will do peer reviewing, exactly like as it happens in the real conferences. Then there will be a presentation, there will be a revision of the paper, and then finally, after the presentation, you get your grade, which is not only about the quality of your project, but it's also about the quality of your reporting. Believe me, it's the most useful thing in the world, because the way you report it and present it really can mean the death of the birth of a new thing that comes from your own brain. If you present it well, then it goes on. If you don't present it well, you can have the best idea in the world, it remains in your pocket. So this is a good, excellent course that I recommend everybody to take. It's not mandatory, but we've had a lot of satisfaction out of it. This is the festival that I was mentioning before, the students that go down to Sicily and do this. This is kind of fun because the lights are controlled directly by the music, by features extracted from the music. So it's kind of fun to see. We also interact with musicians. This is Boris Savoldelli, and that's actually kind of funny. This was an old picture. This is Bruno Di Giorgi, now is the head of research in a research lab in Apple Music in London. Back then, he was a PhD student. Just last week, we worked for 2 days with Maria Pia De Vito, this famous singer, because she wants to do solo concerts with the voice. So many technologies being developed for that idea. We had hackathons and challenges. The hackathons, we participated twice to the Red Hackathon before pandemic in London, and actually one group of students won the prize of the Red Hackathon of the Abbey Road Studios. Next year will be the proud holders. I mean, we will hold the conference of Izmir, which is the Music Information Retrieval Conference, it's an international conference in Milan. There will be over 500 delegates from all over the world, and we will have students participating in this conference helping us out, but also we'll have a huge hackathon at MEET, the Digital Cultural Center in Milan, and which will be very much in this style as you see right here. Facilities, very quickly because there is another presentation after this. We have a musical acoustics lab where you have arrays of microphones and clusters of microphones that can be used. These arrays of microphones were actually designed by us. They're called plain acoustic capturers, and they are quite amazing the way they work. This is a session in which, for example, a violin player in the lab, in Violin Museum, we have this semi-anechoic chamber. The violin player plays, and in real time, you can extract the radiance pattern of the violin. So you can, the distribution, the spatial distribution of the power produced by the violin itself, with a very creative solution. The first version was using also a Kinect to track the motion of the violin, but the later solution didn't even need a Kinect anymore. And you get the radiance pattern of the violin itself, just to give you an idea. We actually study all the historical instruments of, in the museum using this technique, having them played by a musician in the chamber. We have facilities for measuring this was, by the way, the Messiah, the Stradivari Messiah. We had police outside. It was over, nobody knows how much it's worth, probably 50 to 100 million euros. So we have police outside and nobody could breathe. It was a story that I will tell you some other time. This is measurements done on the Faltioli piano. The laboratory has a lot of interesting facilities. This is for measuring vibrational characteristics of the violin. So this is part of the lab in Cremona, the musical acoustics lab with a laser scanner, vibrational aspects. You can look inside the violin and there are X-rays, laser vibrometry, all kinds of stuff that you can do in there. That's Professor Antonacci doing work with the laser scanner. This is accelerometric mapping, and so on. This is the musical acoustic labs for the rendering. So you can have 3D audio. These are the first installations of 3D audio. We use them for perceptual experiments. This is the studio lab for doing production. This is the anechoic chamber in the Pollini Sound and Vibration Lab. These are some of the arrays that we use for near-field holography. And the master thesis is what I mentioned before. It's quite amazing to do a master thesis here because the students have done the wildest thing. This, for example, was a project called the Sound Resonance Project. We were capturing sound in 3D during a concert when trying to measure the emotion of people using bracelets that capture the electrodermal activity, blood pressure, and so on, and then mapping it and finding a correlation with the musical descriptors. It's kind of interesting. Also, this is a project on dance, for example. It was called the European Project on Holodance, where you see we were recording the motion of dancers and creating databases of motions, correlation with music, and so on. And even we could actually have virtual dancers dancing using the database of motions along with the dancers themselves. This is an example of that. And they were wearing HoloLenses, and so the virtual dancer will be dancing along with them in a situation like that. And many students actually participated to this kind of project. But okay, never mind now thesis. I just wanted to give you an idea. The reason why I told you all about it is because I personally, as a coordinator of this program, believe in the importance of never keeping research and teaching separate, especially at the master level. The two things are actually mingled together very, very tightly. PhD students take care, each one of them work with 4 or 5 thesis students. And PhD students collaborate with each other, form research groups inside. They're all students are taken care of individually. Then the interaction is also with the professors. Everything is very, very tight and solid. And the quality of the thesis is a good indicator of what's happening there. Many, many students go home with publication in their pocket, in their CV. So that's something to be really proud of. What do you need to be admitted? Just very briefly, this is probably the only, we knocked down one wall. The Polytechnic didn't want to hear about this possibility before. You could not access the master's program in engineering before without a first level in engineering. Now, this is no longer true. You can, and actually, we even have PhD students that did, for example, musical informatics at the Statale, the first level, for example, and now they're PhD students in our group. So that means that not only did they complete it, but they did so well as to deserve to become PhD students. Luca Comanducci is one such example. He's a fantastic PhD student. And he came from from a non-engineering university. There are many, many other examples. I'm not going to give you all the names, but you can do that. It just takes a little more work because there are many topics that need to be realigned, but you can still do it. If you don't have a degree in engineering, you can still come in as long as you have 30 credits, ECTS credits, in the areas of math and physics, and another 15 credits in the area of computer science. If you have those, because you took something more or less in that direction, you can access without any condition. If you don't have them, there are always courses that you can buy, let's say, or you can take in advance in order to realign yourself with the minimum requirements to accessing the course. Then there are a certain number of things that it would be good if you knew. For example, circuit theory is always useful. Not because you have to build circuits, because physical modeling is based on circuit theory. So if you want to do modeling, some serious modeling of vibrational structure, you need to know circuit theory, surprisingly enough. We tend to dismiss theories just because they're not fashionable anymore. That's not true. Modulation theories is useful for voice modeling, even if the radio is no longer there. All theories are always useful. We are truly interdisciplinary. So we can tell you what you need just by interacting with the committee that does the admission, okay? But like I said, many students not in engineering were extremely successful thanks to this. Let me just show you one last thing, and then you can ask me very, 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 very few questions because I'm already overboard as far as time is concerned. Usually students ask me whether there is music in music and acoustic engineering. The answer is yes, there is, but it's not the topic of study, obviously. Students that want to play can always join Polyphonia, which actually was born exactly when this degree started. So there was a need, and the need was covered. It's a fantastic association with very good teachers. There is a choir that is incredible because it's directed by Giorgio Brenna, and so on. Then there is the Interplay project, which I direct personally, and we did a concert just last week. And many students participate. We select, obviously, a certain number of students because this goes outside. It's not just inside the campus. And we've done very, very interesting things. The Interplay project now has, in the last concert, had 13 musicians coming from all over the world. And the result was actually quite nice. It's all original music, so it could be an interesting place where you test your ideas if you come up with a good idea, and this could be one possibility of doing that. And whenever there are good ideas, we do the best we can to put them on display. Okay. Any questions? Go ahead.
I had a few questions, but you answered last.
Okay.
But in your opinion, which is the most proper bachelor's degree for college best? Both in music or
well, indeed, so the question is, which is the best, the most suitable first level bachelor degree to access this? I think the one that you always need to do matching, right? So the most matched one is any degree in the area of information engineering, which could be electronic engineering, telecommunication engineering, informatics engineering. So if it's engineering, you never have trouble. You never have debts, let's put it that way. Or automation engineering. These are all information engineering areas. If you have a degree in mathematical engineering, it's great. If you have a degree in physical engineering, it's fine. Mechanical engineering is just as fine. You might need a little boost in computer science, but it's something you can do during the program. You don't need any boost. You don't need anything if you do one of those information engineering.
So if I'm not an engineer still, I have to struggle. We are from
musical informatics. I think we've had many students from there. They had to work a little more because you're earning a master in engineering, so there's nothing to do. But it's neither impossible nor super hard. You just have to do those few things that you need in order to realign. If you want, we can have a conversation about it when I get out. So it's something that we can discuss in Italian, if you prefer. Yeah. I don't know if there are any questions from remote. Okay. Okay, so if anyone from remotely connected prefers to have a conversation with me, you can write me an email to augusto.sarti@polimi.it, and I'll be happy to answer. Or we can, if there is a sufficient number, we can also have a separate session of Q&A via Zoom or whatever is needed, okay? Just write me and let me know if you have specific questions about it. All right, so let's close here. Thank you very much for being here, and goodbye to everyone who's connected remotely.